Hello friends, I welcome you all to this session on numerical methods using C++ programming. So in the previous lecture I told you there is a method called as trapezoidal rule to find out the integral of or definite integral of any function. So this is the formula, and there was one mistake in this, that it should be 2 times this because 2 is present. So now let us write the code for it. So first what we should have is, first we will tell how many trapezoids are there. Then we will give the limits, that is a and b. Then based on these two, what we'll do, we will find out what is h, that is b minus a by n. Once this is known, then we will be first declaring one array, this, and this particular x array should have n, or let us write it correctly, should have n plus 1 number of terms. Okay, and how to declare it? The ith element of this array will be nothing but I times h, isn't it? If you look here, this is the 0th element, so here x, as we are starting from here, so it should be 0, and then it is okay. If you want like this, then what you can do is, instead of writing I times h, what you do, you start from here, a plus I times h, so plus a. That is much correct. Okay, instead of creating as a dummy reference, we will be writing like this. So when I becomes 0, it is a. When I becomes 1, that means this one, so it will be a plus h. Then when I becomes 2, it becomes a plus 2h, and so on. So that is how we will be creating array of x. Okay, then once this has been done, then we will be creating a variable s and assigning it the sum of function at a and b, this term. Then we will be running a loop. The last part will be running a loop from 1 to the last term, because how many data points are there? N plus 1. So we'll be running up to this point, because internal nodes will be working on, and then we'll be doing what? Summing them up. That is this plus 2 times fxi. Do not forget this 2. Okay, and that's it. Once this has been done, then you find out the area, which is nothing but this s times h by 2. So let us write code for it. So first we should have some function. Let's say I'm interested in integrating this x square. So this is my function. Then if I do it analytically, I should get x cubed by 3, 0 to 1, that is 1 by 3, that is 0.3333, and so on. This should be my answer. Okay, and apart from these all, there is one 0th step also, and that is what? Writing the function. So let us do it. So first I will be declaring one function double, and this function, sorry, x, and this will be returning what? X square. So it is power x comma 2, because I have already taken math module here. So once this is done, then you create the number of trapezoids. So let's say the number of trapezoids are 4. Okay, then you create the left limit, that is 0. No, is it 0? Yes, it is 0. And then the right limit, that is 1. In this case, look here, the left limit, the lower limit was 0, the upper limit was 1. So 0 and 1. Once this is done, then we'll be declaring h, that is the width of one trapezoid, which is nothing but b minus a divided by n. So once this is known, then we will be creating one array of x having n plus 1 terms. Then we will be initializing this array. So for int I0, I less than n plus 1. This is very important. I plus plus. Then here what we will be doing? So xi, ith element, will be nothing but a plus I times h. That's it. So if you want to see what is my array of x. So this is my array of x starting at 0, ending at 1. 1, 2, 3, 4, 5. 5 elements are there at a spacing of 0.25. Okay. Now this is not required. Now we'll be creating one variable s. Okay. And we'll be assigning the values of function at a and b, that is the sum of those, to this s. Once this is done, then we'll be running a loop starting at 1, because we are only interested in finding the remaining sum for the internal nodes, that is 1, 2 and 3. So 1, I is less than what? It should be, yes, n, you are right. And then you just have to say s assign s plus 2 times f of xi. Once this has been done, then you can simply say the area, let us create one more variable, area, and that will be equal to h by 2 times s. That's it. Finally print it, see out the area or integral, jo bhi, whatever you want to write, and that will be equal to area. That's it. Done. We have written our full-fledged code for the trapezoidal rule. Okay. So if I run it, it will give me an answer of 0.34375. Why it is not giving 0.33? The reason is very simple. Because of these. So if you look here, there are areas or the portions which these trapezoids do not consider. So these are missed. So due to this, error is propagating in our program. So what can we do is, if this is my original curve, let's say, and if I increase the number of trapezoids, then this will be very close to the curve. Okay, so because of the number of trapezoids, the error will get reduced. So let us see this also. Let us increase the number of trapezoids from 4 to 40. So if it is running, so if I run it now, then you can see it is 0.333. If you increase it further from 40 to, let's say, 500, then you can see it is very close to our expected answer of 0.333. So in this way, friends, you can increase the precision or the accuracy of your problem. So let us take one more problem. Let's say I am interested in finding out the integral of sin x from 0 to pi by 2. Okay, now if you solve it manually, it is minus cos x from 0 to pi by 2, that is minus of 0 minus 1, so it should give me 1. Okay, so let us see whether we are getting the same answer or not. Now, what is my function? It is now sin x, so I'll be writing sine of x. Okay, I'm having CMath already, so sine will be there with me. Then the lower limit is 0, upper limit is pi by 2. So it is math pi, this function is there in CMath, and then pi by 2. So if I run it now, I should get an answer of 1. So it is very close to 1. So in this way, you can evaluate the integral of any function using trapezoidal rule. There's one thing which you might have observed, that if I reduce the number of trapezoids, then the accuracy is less. Whereas for more accurate result, I have to go to higher number of trapezoids. This will consume the memory, this will take time. So there are methods such as Simpson's 1/3 rule, Simpson's 3/8 rule, which are much more accurate than this particular method. As you already know how to program trapezoidal rule, so it will become very easy for you to program Simpson's 1/3 rule. So what we'll do in the next lecture is, we will first try to understand what is Simpson's 1/3 rule, and once this is understood, then we will be programming it. So in this lecture, till this point only, thank you very much for watching it.